Recall that what concentration expresses in a quantitative way using numbers is the amount of solute that is in a given amount of solution. Now there are several concentration units, but the one that is most common in the laboratory is molarity. And molarity, which is abbreviated a capital M, is the moles of the solute divided by the liters of the solution. So look carefully here, because the units for molarity are different than the units we used in percent concentration in a previous video. So simply, the concentration in molarity, which I can use as a capital M, is moles of the solute divided by the liters of the solution. So let's see how we would use this equation to solve problems involving molarity. So this first one says calculate the molarity. So when I see that, I think to myself, molarity equals moles of the solute over liters of the solution. And we want to calculate the molarity of a solution that contains 2.0 moles in 0.250 liters. This is the simplest of all the molarity concentration problems, because all I have to do is take the moles that I was given and divide it by the liters that I was given, and then I have my molarity. Now recall, in the previous one we had percent concentration, and in percent concentration we multiplied by 100 because it was a percent. But in this problem, we will not multiply by 100 because molarity is not a percentage. So to two significant figures, the molarity of this solution would be 8 molar. So here's another question, and it's asking me about the molarity. So in my mind, molarity equals moles per liter. And this time of an IV glucose solution prepared from 108 grams of glucose with a molar mass or a molecular weight of 180.2 in 2 liters of solution. So I think to myself, molarity equals moles of solute over liters. Well, I already know that it's a 2 liters of solution, but they did not give me moles. Instead, they said I had 108 grams. So before I solve, I have to convert 108 grams to moles. So to convert, remember, grams to moles, we're going to use the molar mass, and the molar mass is given to us in this problem. But if you recall, to calculate the molar mass, you would need the chemical formula, and you add up all of the masses of each atom as found on the periodic table. In this case, going from grams to moles, I will divide by the molar mass so that my units of grams cancel. And so if I say 108 divided by 180.2, sorry, I messed up my calculator, 108 divided by 180.2, and I get to 3 significant figures, 0.599 moles. So once I know the number of moles, I can plug it in up here. And I'm going to divide that by 2. And to 3 significant figures, I did not round it in my calculator. I just used what was in my calculator, and I get 0.299, and then it's a 667. So to 3 significant figures, that's going to round up. It's going to be just to 2 significant figures. 0.30, capital M. That means molarity. So this IV glucose solution would be 0.30 molar. And here's another example, and again, it's asking me to calculate the molarity. So I think to myself, molarity equals moles per liter. And so if I want to calculate the molarity, I'll need to know the moles of the solute and divide that by the liters. So looking at my problem, it tells me that my solute is 12 grams of sodium chloride, and the liters of my solution is 200 milliliters. So I don't have the right units just to plug in. So I need to convert the grams to moles. And I can do that first. I write down the grams that I'm given. And just like I did in the previous problem, I'm going to use the molar mass, which is given here. That was calculated by adding the sodium and the chloride ion together, the chlorine together. I'm going to divide by the molar mass, so my grams cancel. And so 12 divided by 58.44 is, it's a 3 significant figure, 0.205 moles. And then, because I was given milliliters, I need liters for molarity. So milliliters to liters. So it's 200 milliliters. I'm going to divide it by 1,000 because there's 1,000 milliliters in 1 liter. And I get 0.200 liters. So I take the moles that I calculated and I divide it by the liters of the solution. So 0.205 divided by 0.2 to 3 significant figures, I get 1.02669. So to 3 significant figures, I get 1.03 capital M. So you can see calculating molarity, if we're given moles per liter, we can just plug it in. If we're given grams, we have to convert grams to moles using the molar mass. And if we're given milliliters, we have to convert to liters, remembering that 1,000 milliliters equal 1 liter. Now sometimes the question does not ask us to calculate the concentration, rather it asks us to find a different part of the equation. So in this question, it says, what volume in milliliters of a 0.3 molar solution? So they've given me the concentration this time. Before I was asked to find the concentration. And it says, what volume contains 0.25 moles of glucose? Now there's 2 ways to find the answer to this problem, and I'll show you both. You do not need to use both ways. You need to practice enough that you know which way is the best way for you. So the first way is to use just your math. So I know that the molarity, the concentration, equals moles over liters. So they've given me the molarity, and they've given me the moles, and I don't know the liters. And I'll just put L there for liter. You could put X or V if you wanted, or maybe instead of using the unit, I'll put V. So to solve for V, I'll multiply it up because it's in the denominator right now. And this is what I get. And then I'll divide the 0.3 over, so I get 0.025 moles over 0.30. So when I do that, 0.025 divided by 0.3, I get 0.08333. Now this is liters. Looking at the problem, it wants it in milliliters. So to convert it into milliliters, I remember that there's 1,000 milliliters in 1 liter. So in order for the liters to cancel, I multiply it by 1,000. and I get 83. I guess it would just be 2. It's 83.33, but I guess it would just be 2 significant figures, so I get 83 milliliters. Now the other way is to use molarity as a conversion factor. So in molarity, it's telling us how many, whoops, I said conversion faction. It's telling me how many moles there are per liter. So when I see this, this is given, what it means is I have 0.30 moles in 1 liter. So that's what this concentration means. Because it's a 0.30 molar solution, it's 0.30 moles in 1 liter. And anytime I can write something with a numerator and a denominator, I can use this guy as a conversion factor. So I write down the other information I knew, which was 0.025 moles. I don't start with my conversion factor. Then I'm going to multiply it by the conversion factor right here. But I want moles to be on the bottom, so they'll cancel. So I'm going to flip it. And the moles cancel. And I get 0.25 divided by 0.3. And so I get 0.0833 liters, just like I did before. And then changing that to milliliters, I would get 83. So you can see why I like using it as a conversion factor, because compared to the algebra, I really just have this one step. But it doesn't make it the right way for you. You need to practice using algebra, maybe try it with a conversion factor, and see which way is best for you. Now let's try another one. And this is also going to be one where we can use concentration as a conversion factor. And in this question, I'm trying to find grams of aspirin. So this is going to be my solute, contained in 50 milliliters. So this is my solution of a 0.05 molar solution. So this is my concentration. So let's look. So molarity equals, this is using, let me label it. This is using algebra. We'll just solve it. So I know molarity equals moles per liter. So that means 0.050, which was given, equals the moles. So I'm just going to put, I'll just put M, the mass for moles, and in 50 milliliters. Okay, so it's per liter. So I have to divide, there's 1,000 milliliters in 1 liter, so I have to divide, so 50 milliliters is 0.05500 liters. So then I got to plug that in. So then solving, I have 0.0500 liters times the concentration equals the number of moles. I don't want to use M because that might make you think it's mass. So 0.05 times 0.05 gives me 0.0025, this is moles. Now they want grams. If you look up here, so to go from moles to grams, I have to use the molar mass, which was given. Remember to calculate the molar mass. You add up, we'd have to have the formula. They don't give us the formula for aspirin. So I take this and say 0.0025 times 180.2, and I get 0.4, how many significant figures? 2. 0.45 grams. So rereading the question, because sometimes we get so involved in the math we forget what we're trying to solve for. It says how many grams of aspirin are contained in 50 milliliters of a 0.5 molar solution, 0.05, molar solution. So there's 0.45 grams of aspirin in 50 milliliters of this solution. Now the second way to try this, and we'll get the same answer just to show you side by side, would be using a conversion factor. And I know that 0.050 capital M, that means I have 0.050 moles in 1 liter. That's what it means. The concentration is always how much solute you have in your solution. So I would write down what I was given, and it has to be in liters, which I already converted to. So I have 0.005 liters times, I'll put the 1 liter on the bottom so they cancel, and the 0.050 moles on the top. The liters cancel, and that gives me 0.0025 moles. Then I would multiply by the molar mass like I did before, and I would get the 0.45 grams. So you can see here to go from liters to moles, using it as a conversion factor, that's what I did, that middle step. In both problems, remember the first step I had to do, I had to change my milliliters into liters. In both ways you'd have to do that. And then the final step, is I had to change my moles into grams based on what they were asking for. So here's a few different problems and how you use molarity in calculations. Review these questions and practice some more.